Welcome to Program Rainbow. In this video, we will continue on the series of the Beginner's Guide to SDL3 in the C language. So if you're just starting out with this one, you can go to github.com, Programming Rainbow, and this one will be called Beginner's Guide to SDL3 in C. You can git clone this repository, move inside the directory, and open it up with whatever editor you like. You don't need anything special for this. Okay, let's look at the code. This is just a terminal right here. I'm using NeoVim. Like I said, you can use whatever editor you want. It doesn't matter. This is all just terminal. So I'm just going to show you what the final project is going to look like real quick. It's going to open up a window. It's going to play music. It's going to have text moving around the screen. It has a background drawn. It has an icon that you can control. It has a title on the window. It has an icon on the window. So I'm going to show you all that, and it will be playing music at the time. So here it is. Here's our background image. Here's our true type font bouncing around. Here is our icon that we can control. I can move it around. Here is our window icon. Here's our window title. And I can change the background. And it also says C every time I change the background. And every time SDL bounces off the side, it says SDL. Okay. So that's just showing you the final project. That's just lots of different things, showing you how to do many different things. So when you want to make your game, this is all the basics that you'll need to start making simple games. Okay, so, but that's not where we stopped up in the last video. Last video, we opened a window. So this one, we're going to close a window. We're going to create a game loop, and we are going to deal with events. So requesting to close the window is an event. So we're going to be dealing with that. I'm going to close this one. Oh, this is actually the source file from the last video. So real quick, I'm going to remove this guy right here. This will be actually added in a later video, but right now we're just going to let it be black. In the cleanup right here in game free, I really want to know if this function got run or not. So what I want to do is I'm just going to add a print statement here. Just for me to visually see with it. So if I have multiple different steps that are shutting down, even if something fails, I want to visually see that things were shut down in the order that I think that they should be. So this is just a print statement. Just for me, it's not important. Okay, so I'm going to say all clean, right? Now let's give it a new line character. Okay, so that again, that's just a print statement for me. So let's change the title of this before I get to close. Oh, I'm going to change this back to its default, which was 800 by 600. We were just messing around at the end of the last video with the resolutions to show that it can be different resolutions. And I'm going to tell it to delete. So I was using the make command in the beginning, and that created this binary. But you don't need this make command at all. This is not part of this project. It's just thrown in there as an extra. I just want people to understand the actual command at the command line. So this would be GCC, the source file that you want to build. And this -o is the output binary that you're building. And since we are using SDL3, we need to link it because we're using the system's SDL3 library. So that is the linking. And this just says if this command right here was successful, then let's go ahead and run it because this is outputting a demo binary. So this is saying ./demo is to run it. I'm also going to just remove it in the beginning. So it's going to delete demo. Let's just see each one of these happen separately. So that deleted demo or removed it. And then, so this one is GCC. Like I said, in the source directory, we have main.c. If we had more than one C, I could actually just put an *.c here, but we're only dealing with one file. So source /main.c, and then this -o is the output, and we just want the final binary, so it's going to be called, I'm just calling it demo. And then we do need this linking, this -l SDL3, that's linking against our SDL3 library. So this is going to create right over here a binary called demo. There it is. And then to run it, we go /demo. Okay. And this is going to close after 5 seconds. It's not going to listen if I attempt to close it, but we're going to fix that in this video. Okay, so I'm just going to put all those together in one line so I can just run them easy. I'm just going to remove it as well. There's no need to remove it or replace it, but just for myself, I'm just doing that. Okay, so this just deletes it, builds it, runs it. We don't need a makefile. We don't need anything. That's very simple. Okay, it's going to close after 5 seconds. So that's enough of that. So in this video, we need to create the game loop so that we can paint the window over and over again. But if we did that, we would have an infinite game loop that would never close, because we need to know if we have requested to close a window or pressed a key to close. So the first thing we're going to do is start talking about events. So we need to run this function here, pull event, to get one of our events off the queue of events. So let's just go up here again. I'm just going to open this up here. And I'm actually going to do the one from video 2, which is what we're targeting right now. So this window is going to stay open, right? And actually, as I move my mouse across it, each time the game goes through a game loop, that's an event. This mouse move is event. If I click the mouse, that's event. If I press, say, space bar or escape or anything, well, that actually closed on escape, but you get the idea. If I do something, that's an event, and we want to process those events. So we're going to create this game loop, but then we need to know what were all the events that happened since the last time through our game loop, and then we can grab one of those events one at a time and look at each of them. And the first thing that we're interested in is if that event was a close event. So what this does is SDL has a queue of events. All the events have happened since the last time you've gone through and cleared the queue. And it's going to have mouse movements, key button presses, all kinds of different events. And we're just looking for if event has been closed. So what this is doing is we're sending in the address of an event, which is going to be a union. It's going to populate it. If it did populate it, it's going to send back a 1 right here. It returns true, sorry. In SDL2, it was a 1. In SDL3, it's returning true. So if this returns true, this did get a good event. So we could right away put this into a while loop, and we can just keep going through our events until we've run out of events, because it's going to exhaust the queue of events. So let's look at what this event is right here. So this event is a union. That means it can have any one of these structs in it. It's not going to have all of them. It's going to have just one of them. So the first thing that whenever we're dealing with a union is we need to check the type. All of these structs have this type member. And so we can check that right away. And down here towards the bottom of this is all the different types it could be. And we are looking for, and it's slightly different in SDL3. Instead of SDL quit, it's SDL event quit. So it kind of makes more sense now, the way they've written it. So they are written slightly different than 2, but not a lot different. They're basically they all have underscore spaces in them now, and they all have event in them. So if you're coming from SDL2, it's very simple. You just put add event to it and make sure you add spaces, and then it's going to mostly work out. So we're looking for SDL event quit. That's going to be the type. So something, one of these things in here, one of these structs is going to be inside this union. And we're going to check the type and see if it's a quit type. If it is, we actually do not care what's inside the struct at all. We're just done there. We know something is a quit event. We don't care what it was. We just know that something's requesting our program to quit, and that's going to be good enough for us to say, I think we should quit this program. Okay? So we have this event. We have this function that goes through our events. It populates them one at a time, keeps going true. If it was populated, we can put this in a while loop, and it's going to populate this type that's an event here. And we're going to check the type on this event to see first if it's an SDL event quit. If it is, we're going to shut our program down. Okay, so that's the first thing that we're going to do here. Okay, here's the sample code. So remember I said we could put this in a while loop right here. So here is the function, the pull event function. We're passing in the address of event. They've declared this event up here, which is of type SDL event. We pass in the address of it. If this function does populate this, it's going to return true. So this while loop will still be good. And then we can process that event and see if it's an SDL quit event. So I'm going to do this thing right here because this allows us to go through all of the events. And this basically is inside of a game loop. So we are going to set up in this video, this game loop right here. We're going to make our own Sentinel value. And we do need this event, but I'm actually going to put this in the game struct. We don't need to keep instancing it on the stack in this scope. There's no reason to do that. And then we're going to pass in the address of it in a while loop and exhaust our events. Okay, so that's what I'm targeting. So the very first thing I want to do here is put this event in here. And you can call it whatever you want. They called it event. I'm also going to call it event because that's just descriptive. So I don't need to document what it is. It says what it is. This is just a union. So this is not a pointer to anything or anything like that. And I'm also going to make a sentinel value for my game loop. Since I'm here, I'm just going to call it is running. And this is just a bool. This is going to be my game loop is going to run until this bool is not true anymore, basically. So I'm just putting that up there. So right here, I'm going to turn this into a game loop. So we're no longer going to need this right here because it won't matter because this is looping over and over again. So we'll just do while. And this will be G is running. So while that's happening, we want to go through our loop. Okay. Now the problem with this, well, we have two problems with this right away. One of them is our game loop is going to take 5 seconds, which is way too long. If we want to target something close to 60 frames a second, we could take 1000 milliseconds, which is 1 second, and we can divide it by 60. And we're going to get 16.6, 16 and 2/3. So it's going to be 0.6 on forever. I'm going to drop the 0.6 and say it's good enough to just put 16 in for now. For this simple game, I'm just going to put a delay. Plus, the logic of our game takes up a certain amount of time. So it's going to be good enough. So 16 millisecond delay. Now we're close to 60 or 62 frames a second. The problem is you do not want to run this code right now because the second problem is we have no way to get out of this while loop. We have nothing that's changing this running to false. And actually, the running is false by default right now. We haven't set it to true. So this won't even run at all. But if we did set it to true, we could never get out of it. So we want to look at our events. And I actually don't want to put them in here. I could put them right here, put another while loop in here. I'll just show you what it would look like. And we're going to use SDL pull event. And then we need to put in the address of an event to populate it. And then we could start processing it, right? And if we get a quit, we can do it. So I'm going to keep writing it here, but then I'm going to move it out of here. Okay. So I want to use a switch case to look for the event because I'm going to be adding different checks later on. So I'm not going to use if else statements. I'm going to use a switch. And what I want to switch on is the type of the event. That's the most important thing. Before we look at anything about any struct that could be in that union, we first need to know what type it is because it's going to be one of those structs and we don't know which one of the structs it is. So the type is the most important thing. So if this has been populated, this while loop is still true. And we can go type. And right here, we can check the case. And again, the case that we want to check is this type SDL event quit? That is the case that we're checking. So this is SDL event quit. If it is an event quit, we want to quit. So the way that we can quit this while loop here is by changing this Boolean value to false. So is running, you could say equals false. And I want to break here. I also want to put a default where it's going to complain that I'm not checking all the cases. So this is going to just be a default. Okay, let's see if I've got all my squirrely braces lined up. It looks like I got it correct. So we have our switch. We're checking this case. If this case, we don't even need to look at the struct that's inside of it. We're not even going to deal with that. We just know some quit event has happened. Let's quit. So we're changing the bool to false. We need to put a break on any of the, if you know how to switch, unless you want it to fall through and do the next one as well, we put breaks on. we need a default case or it's going to complain depending on your compiler. So I don't want this here. I'm going to break this out into its own function. And this one is not checking for any errors. There's no error checking happening here. So it's going to be void game. And I'll call it events. Same thing. We're passing the pointer of the game in. And I'm just going to take this right here and put it in here. And I will call it events, and we'll just pass in G here. We do need to forward declare this right here. Bring it up here to it's before run. Okay, I also want to, while I'm here, I don't want this drawing here. I'm going to break it out into its own function as well. So I'm going to create another one. Eventually we'll have an update one as well, but right now we're not updating anything. So I'm just going to break out the drawing into its own. And again, I'm not checking any, I'm not ever going to be checking anything on the drawing in the game loop. If I'm ever creating something, an image, where I need to create the texture or load a texture, I'm going to definitely check that. Even if it's in the game loop, if I'm creating a new texture, I will check that. But if it's simply drawing something to the render, I'm not going to check it. It's not important. If something does fail, it's not catastrophic to the game. So I'm going to call this draw. And I'm just going to grab these right here. This is dealing with drawing. And these will get more complicated later, so that's why they're going to be in their own. And then I can just call game draw here. And pass that G in. And then forward declare. And then we'll test our game. I should have tested it before I moved all the code around because that's kind of doing a lot of edits at once. But it should be okay. It's still pretty simple. So what we've done here is we've pulled out, we've created this event and it's just checking if any of the types is event. If it's not, it's just going past it and it's clearing out the entire queue. Okay. We've taken all our draw, pulled it out into its own. So this game loop is running continuously. It's checking the events, it's drawing, then it's delaying 16 milliseconds. And it's doing this over and over again. Every time we get back up here, whatever events since the last time we cleared our events, whatever events happen, imagine this is finished. Now we're here and then we're here. Whatever events happen here, mouse movements, clicks, keyboards, any events, those events now are put on the queue. And when we get it back up here, we have a new queue of events. So that's what's happening. And this goes through and exhausts our queue of events and see if any of them are quit. If it's any other type of event, it doesn't matter. It's going to ignore it. Okay. This is all the same. So let's check this. Basically, what this is going to allow us to do is it's not going to close after 5 seconds this time. It's going to close when we when we tell the system to close it. Whatever system you're on, if it's an X, you could probably use a keyboard shortcut. It's gonna, whatever your system way to tell a window to close, that's what we're looking at. And this is video source directory that we're dealing with. Okay, so this is the code of what we've just modified. And it says all clean, which is great. It's clean, but why didn't it run? Well, because we never set is running to true. And I'm going to actually create another function. And I was kind of holding back on taking this off the stack and putting it like heap allocated, but I think I'm going to show that in this video too. But just right now, just to see it run, under initialize, or sorry, yeah, I'm going to put it under here. I'm going to do a game new, and this is right now going to be void, but later on it will not be. So this is like kind of like going to be our constructor for our game, setting any default things. So we need to set is running to true. So I'm going to do it here. because I'm going to make this anything else that needs to be done to create the new game is going to be done here. It seems a bit silly right now in the way that the game is, but you're going to see it will make more sense. So we can say G is running. We set that to true. And I'm going to go ahead and forward declare this as well. So where is it? Right now we're doing this here, right? But since I have game new should do everything it needs to do to set this up. So I'm actually going to change this to game new, which means right away I do need to change this void to a bool, because if this is going to need to run game and initiate SDL, and that can fail. So this needs to be a bool. Sorry about that. I was just thinking about how to set this up correctly. So I need to run this right here, game init SDL, and this can fail. So I'm going to put an if on it. Game init SDL, and if it does fail, I just want to return from this. Return false. And the happy path is return true. Okay, so this now, if this fails, we already have whatever printout happened here. We don't need to print anything out. We just need to pass the failure on down the line. So if this did fail, we are not going any further. We are making this fail. And this is what's going to be called from main now. Down here. So this will be new. Okay. So I know switching around a bunch of code. Sorry, I'm reorganizing things. So now this is taking care of getting our game up and running. Anything that needs to happen to set up game is going to happen here. After I'm going to run it, I'm going to switch this over to being heap allocated as well, just so if you have a bigger project, you can see how that would work. You can, for this size, it doesn't need to be that way, but I just want to show how it works. So we do have this, anything to get game up and running is happening here, which is basically setting this Boolean to true. And now we should have, okay, now we have a window that is open, and it's going to stay open indefinitely. And if we press here, it's going to close. And it says all clean. This events doesn't need to be here. My LSP is trying to be helpful. So I want to show you, like, there's no reason right now game, this struct here is very small. And we are just passing it around as a pointer, which is great. So we're never passing the actual struct around. We're passing the pointer to it around. But this struct is just on the stack here. But say you had a really big game struct or whatever. I'm going to show you real quick. I didn't have it in my notes, but I'm just going to do this just for an option or whatever to show you how to set it up if you want it on the heap and not the stack, not right here, because we're literally creating a struct right here on the stack, and we're zero. It's everything's set to 0. What if we wanted this on the heap? Well, I'm going to do this up in game new, right here, game new, and I'm going to use, what I'm going to do is I'm going to switch this over right here. I do not want the pointer to a game. I want a pointer to game. So I'm going to do this, and my style is to now write the whole word game when I do this pointer to pointer. Don't worry about the complaining right now, because up here, you know, like in multiple places, it's going to need to be changed. Okay, so I got a pointer to game. The reason why is I want to send in a pointer to game, and I want to populate it. To do that, I need a pointer to a pointer. because I'm not changing one of the members of game. I'm changing the actual game pointer itself. So I'm going to go down here. Right here, this is no longer going to be like this. What's going to happen here is I'm going to have a pointer to game, and I'm going to tell it to be equal to null. So I got to, now I have a pointer that is null. To be able to change this pointer to be anything other than null, I'm going to need to send in the address of it. If this pointer had members, I can just send in the pointer, that's fine, and I can deal with the members. But since I'm actually allocating an address to the actual pointer, I need to send in a pointer to it. So I need to get the address of this pointer. So this code still works right here. This one right here doesn't for right now, because now this is already a pointer. This wanted a pointer, it's good to go. This needs a pointer to a pointer. So since this is a pointer, I'm getting the address of it. Okay. Right now this as well just needs to be that, although these are going to change, some of them. So this struct game is a pointer to a game struct, and it's set to null. So we need to allocate it. I'm going to allocate it inside of new. Okay, so right in here, I'm going to use I'm not going to use malloc, because malloc allocates memory, but it is not initialized, and that memory has random garbage data in it, and that is not something I ever want to do in C. I never want to deal with anything that has uninitialized data. So I am going to be using calloc instead. Okay. So what I need to do here, since this is a pointer to a pointer, I need to dereference it. And I'm going to set that dereference pointer. So this is how I'm setting the pointer inside of here. I send in a pointer to a pointer, and then I dereference it one time. Okay, so calloc, I need a number for how many of these I want to allocate. I only want to allocate one, so it's a little different than malloc. Then I need the size of what I'm allocating. So I'm going to go size of, and it's the struct. So struct game. So that is allocating a pointer to the real one, to the actual one that is here now. So that's why we needed to send in this address so we can actually affect the real pointer that exists. But right away, we need to check this. So I'm going to kind of use this guy right here. It's going to be similar to that. But if calloc fails, I get back a null pointer. So right away, I need to check if game is a null pointer. So I'm going to say game. I keep needing to dereference it now, because this is a pointer to pointer, and this dereference is at one time, so it's just a pointer. This is the proper way to do this. Okay, I'm just writing it explicitly here. I could have put a bang right there. That would have been fine, but I just want to write it explicitly. I'm going to say error in, this is not an SDL error now. So I'm going to get rid of this. Just put a period here. And I'm going to say error in calloc of new game. How about that? So there's my error message, and I'm returning false from here. Okay. So that's going to let me do with that. But these are looking for G. Now, right away here, I could keep doing this right here, G. Like I could keep doing that, but that gets annoying, because right here, I need to do this. I need to put it in parentheses and go game. I need to keep dereferencing game over and over again. So since I'm lazy and I don't want to do that, I'm going to create another temporary pointer, because for this, I always have this pointer to pointer game. So I'm going to just dereference it one time, and I'm going to do my G again. So G is a pointer to a game struct, and I'm going to have that be equal to the dereferenced game. Okay, so that gives me back, now I'm back dealing with a normal pointer, and I can just put G here again and G here without putting parentheses on it. Okay, so this is, so we've allocated on the heap now, and this game struct is allocated on the heap now, okay? Everything else is still the same, because we're always just passing pointers into all the other functions. But now we have a problem with our cleanup. Our cleanup also needs to deal with the fact that we've just allocated memory ourselves on the heap. So we should take that memory offline as well. So when we get into our game free, we have the same issue. Basically, I can free it from in here. That's fine. But I can't set the pointer back to null. So we would have a dangling pointer outside of here. If game does free, if I were to put more code here, this game pointer is still pointing at something, but the memory has been freed. So what I'm going to do is I'm going to change game to be, again, a pointer to a pointer. The free game, sorry. So these two, the alloc and the free, need to do that. So because I'm changing the actual pointer. So the first thing I want to do here is to make sure that this pointer is in fact allocated. I don't want to be trying to free things if the pointer is null to begin with. So that is the very first thing I'm going to check, and this needs to be game. So I'm just going to put an if, and I'm just going to dereference it one time and say game. And down here at the bottom. Okay. Don't worry, we're going to fix all this. So if the game pointer was in fact not null, I'm going to do the same thing because I'm lazy again. I want to use G over and over again. I don't want to dereference it. Otherwise, I have to put parentheses here in all of these and put the dereference game over and over again. So I'm going to do this. Okay, so now we got our G back. Okay, and we're still freeing the render, freeing the window, quitting SDL. However, now we need to free the actual game. So we could say free G, but I still have the pointer to the G, which is just temporary anyway. It's going to go out of scope right now, but I should set that to null. And I also have the dereferenced game, pointer that needs to be set to null. So it's null outside of here. So I'm going to do both of those. So G is null. So no dangling pointers, even though this is immediately going out of scope. But this one is not. This is the actual one from... This is the actual one that's going to be here. So we can check that to see if this is actually happening. So it's going to complain down in main again because we need to send in the address of this. So making sure game is a good pointer. Now I can make sure the members are good pointers as well before I try to free them. And that should all be good. So right down here, this needs to be the address. None of this is in my notes. I'm just adding it on, sorry. Let's run this and then maybe we'll print out something. Okay, looks like it still works. So I kind of want to print the pointer. Let's say game. Whoops. Game. Is it %p, I think? Something like that. And we'll say game. So this, hopefully, if I'm right, well, let's just see real quick, should be null or something, or 0 or something. Nil. It's funny that it says nil. Okay. It's nil, not null. Cool story. So let's do it here. And then let's do it here. And then let's do it again here. Okay, so we're printing it out after we have declared it. And then it should be populated here. So it should have an address. Checking to see if it still has an address. And then after the free, it should be back to nil if all of this has been done correctly. Okay, so we're in the game loop right now. So we're first seeing it was nil and then it had an address. So that's this printout and this printout. When I close this window, we're past this right here because the game is running still. And I'll have this printout and this printout. Okay, so I still have an address right here. Still good address. Then this free gets run and we get our all clean. And then we're printing it out again and it's nil again. So no dangling pointers, we're cleaning ourselves up correctly. And let's take one of these and let me just show you what I mean up here. So I'm going to print one and let's print G and let's print game. So we'll say this one's G. And then let's print them out after. After we freed it, and then after this. Okay, and I'm going to get rid of all the other ones down here. So we're not looking at so many print things. Okay, so there's no more print statements here, but up in the freeing there is. So what are we looking at here in the free? So I'm printing out the pointer for G and game, and sorry, this needs to be this. Yeah, there we go. So the dereference a game and just the normal G, printing them out before we free it, after we free it, and we should see that this is a pointer. These are both the same pointer. These are still both the same pointer, even though it's been freed. And then we set it to null. And just for good measure, to show that they're all the same pointer, I'm going to print out just one time before it's freed, just up here. We'll call this main game or something like that. And this doesn't need to be dereferenced. Okay, so we should have some printouts. Okay, when I close it. Okay, so main game was this 2A0 ending with that. I'm not going to read out the whole thing, but like this is good enough. So this is the address we're dealing with. G is that same address. Game is the same address. These are after free now. These two are after free, and yet we still have the same address even though we freed the memory. So that's why we need to set them to null. I still find it funny that it's nil, not null. But anyway, so I hope that all makes sense. I could just be talking, like everybody already knows this, obviously, probably. Or maybe somebody doesn't. So maybe that's helpful. Okay, so like I said, you don't need to do this. All of this was just extra because this is so small. This is just handling, what is this, 4 or 8 bytes for each of these. And then this one is probably 4 bytes. This was probably 1 byte or something like that. So that struct size, whatever that struct size is just being put on the stack here. It's not really a big deal. But this is now the heap one. So initially I'm setting it to null. So we don't have, again, an uninitialized pointer. It's going into this guy. We need to send the address in. It's populating it for us. It's allocating memory and actually putting that to the real pointer outside of the function. And then down here in the freeing, we need to do the same thing. Let me get rid of this one as well. And everything else is still the same. And every other function still acts the same. It's only the new and the other ones. All these other ones are still G is a pointer. They're still dealing with us just handing them a pointer. That's fine. We need to add one more thing. I actually wanted to close when we're dealing with key commands. So let's go back here. And we have the SDL quit event, but we also have a keyboard event. Where is that? Here's an SDL key down event. And SDL2, this would have been SDL just key down, not event, and key down was one word, but now they're all spaced out and event is added there. So that is if what's inside the union is a struct that is SDL keyboard event. If that's the struct that's in the union, the type of the union that we check first will return SDL key event down. So we can check this event as well, but then we need to process it further. If it is this type of event, we need to dig inside of this keyboard event to see which key was pressed. So we're going to check event.type and see if it's this. If it is this, then we can check event.key. The key is going into this. It's going to be of this type. So we can check the key member, and that is going to tell us what's inside this keyboard event. And inside of that, there is another struct that is the SDL scan codes. right? And there's no link for this down here, but if you just type in the URL SDL scan code, you can get the scan codes. So this is slightly different than SDL2. There used to be key.keysim.scan code. Now they got rid of the unnecessary keysim part, and it's just key.scan code, which is nice. Okay, so we're going to set that up. So, and this will be added to our event. And what I'm going to do is, first off, we're checking the event. Case SDL event keyboard. And there's a keyboard down and a keyboard up, but I'm just going to check the down one. That's when the key has been pressed down, that event. Key down. I don't know why I'm typing it that way. And I'm going to put the break. If it was this key down event, we actually need to know what key it was. So what I'm going to do is I'm going to put another switch statement inside of this one. This is going to make it simple if you need to add more keys later on. It's going to be very easy to add on other keys once we've set this up. So now I'm going to be switching on the scan code. I already know that the thing I'm looking at is a keyboard event. So I know that the struct is for keyboard. Now I'm going to drill right down to the scan code. Okay, so this is another switch. And if you just had one key that you only cared about in your project, you could just put an if statement as well. It's not really a big deal, but this is more expandable. So let's see, switch on G event, and then it's going to be a dot key, and then just scan code, right? Yeah, directly to scan code, which is nice. And then in here, let's remove one of these. And here we're looking for case that is which scan code, and we'll look at that again. Case. Let's look at the scan codes. So the scan codes are all written the same. SDL scan code underscore and like M for the key M. For escape, it's going to be just escape. For space, it's space. So I'm going to add it to escape so that when I press escape, my program is going to also close. Scan code, I'm just going to pick down and then change it to escape. So if it is escape, I'm just changing the same Boolean, is running to false. And we need a break. And we also need a default. And that should be it. I've typed defaults wrong here. I don't know what's going on. Okay. So we have this switch statement inside of a switch statement. It's fine. And this break is still here like this, or your compiler may complain. But now you can see with this, it wasn't too bad to add, but now I can simply add in another case for each key and do something else. So very easy to expand that. And let's try it out. So this time I'm going to press the space, the M, the H, and now escape. And we see escape close. I'm going to try the normal way to close it. And that closed. So that's very good. That's a way to add other keys that are doing other things. I'm just having it close the window right now, but that should be everything. And so let's just cover what we've done in this one. So we haven't added anything new, but we did restructure a lot of things. I added this function for new that I'm going to come back to. So the first thing we really added was the events, and we do have a new event in our game struct here, which is just, this is a union. The type is SDL event, and we just added an is running as bool. So in the event, we're using SDL pull event. This populates our event if we send in the address of it, and it returns true if there was in fact an event that it populated with. So we can just put this in a while loop and go through all of our events. And since this is a union, we need to know immediately what type it is, because we can't do this key if it's not even a keyboard event. That won't work because it won't be in the union. So we need to know the type first. And for SDL quit, that's all we actually need to know. We don't need to know any further information. So we can just set our Boolean to false, and we put a break on anything that we don't want to fall through, which is everything for me. And we did also add an SDL key down event that we can check. And if we do that, we have a switch statement inside of that again. Now we can drill down to what scan code it actually was. and we can put a case on if it was a escape scan code. We can do the same thing, set the Boolean to false. And there's a default on both of these, or it'll complain that you're not checking all cases, and the default is just break. So we're calling this from run, and we've changed this around a bit. We've taken that sentinel value is running, and we've put that in a while loop. We changed our 5,000 to 16 milliseconds, so we're roughly getting 60 or 62 FPS. And so we're calling that event with our G pointer, and we have broken out draw into its own little function right here. And yeah, so then we went kind of switching around the way that the game, instead of being on the stack here in the main, actually putting it here. Instead, we're holding a pointer, but it's just set to null, and we've changed it so we're sending in a pointer to a pointer. That's so that we can send in this pointer and actually change the pointer that we're sending in. So that's up in new now. So in new now, we're using calloc to allocate our memory, but this calloc, it initializes it to 0. That means all members of our struct are going to be 0. And that includes these being null. So these are null by default now. Event is going to be just 0. This will be false because that's what the 0 is under the hood. So that's what calloc does. Calloc gives us initialized memory to 0. And that's nice. That means everything's either null or the 0 representation of it. And right away, we're checking to see if that was in fact allocated memory. If not, we're giving ourselves an error message and bailing out. And right away, I don't want to keep dereferencing game all the time. So I'm just making myself that little G so I can be lazy. Since we did this game here, we are using the game init SDL from here now, and none of this has changed. This is all just the exact same. So we're just seeing if that's failed so that we can, any failure that happens anywhere collapses all the functions down. So we will see that later when we load an image. I'll show the collapsing happening, but that's why everything returns a bool. If anything fails, it just collapses it right down and it cleans itself up. But we are setting to true here for that. So we did change, or we did create this game new right here. And we did have to change the free because we need to do these right here. We need a free game. We need to set the pointers to null. So the very first thing, we're putting in a pointer to a pointer game. And I write the whole game when I do this. Otherwise, I just use pointer to G. But immediately we need to check to see if this is a valid pointer, because what do you think happens if we go up here? Say we go up here and we go game new and this fails right away. Calloc fails right away. We have a null pointer on game, right? This function is going to get run anyway because down in main, it's going to attempt to run game new. If it fails, it still runs game free, right? So if that pointer was never even allocated and then I start trying to do this, check the member of render, this is not going to work at all. It's going to be like, what's G? G is null. How can I dereference null and check render when it doesn't even exist? So the first thing that we're doing is making sure this is a valid pointer. That's the very first thing we're doing. And again, I'm always checking if each of the things are valid pointers, the members as well. So, and I'm doing my right here, creating a local version so I don't have to keep dereferencing game over and over again. So I can just use G for all of them. But then I'm freeing G, I'm setting G to null and setting, this is the important one right here. This is the guy that sets this game to null. So this is local. G right here is local to this scope. So when I set it to null, that's cool inside of this scope, but G doesn't exist outside of this scope and it doesn't change the original one. But when I dereference game right here and set it to null, that's changing this guy right here. This is going to be null now. So that's why after free, it was set to null. That's what's going on there. That's why I send in the pointer to pointer. I could have done all this other stuff with just one time here. you know, it's going to complain obviously if I do this now because I have these dereferenced and stuff. But if I just did this and it was a G, I could do all these things right here. And I could even do this, but I would have a dangling pointer outside of this. Outside of this function, I would have this dangling pointer in main, and that where it would be freed, but it would still have an address, and I don't want that at all. So that's the correct way, I think, to do that. So yeah, so we modified the free, and we added this little print thing so that we know that this function was in fact run. This is more interesting later on when we have other members here in other games where they're freeing things too, and we can see the way that everything is collapsed down and cleaned itself up. Okay, so I think that is everything. This is largely the same, except this turned into a pointer, and some of the, you know, we have to send in the address, but we were doing that in before, and this one we don't because it's already a pointer, but the rest is the same. So I hope that's helpful for anybody who, you know, didn't quite understand those things in C maybe, or didn't know how to structure things. It's still a simple thing, and like I said, it's not necessary to put the game struct on the heap, but you still may want to know how to do that. And if your struct gets bigger and bigger and bigger, you may definitely want to know how to do that. So that's everything. I hope that was entertaining or enjoyable, and have a good day. Bye.